Thank you, thank you. My name is Anton. I work at TEA as a staff software engineer. My team is primarily focused on onboarding, compliance and risks. And you know, building the onboarding involves like many different distributed systems. Did you work with distributed systems? Sure, of course you did. So you know the challenges, right? And distributed systems don't usually fail in dramatic ways. They fail in small, annoying ways. A retry here, a timeout there, a worker crashing halfway through the process. And suddenly, something that should be very simple, like processing an order or onboarding a customer, turns into a mess of like retries, rollbacks, cron jobs, like halfway finished states. In this talk, I'll show you how Temporal lets you build reliable distributed workflows without worrying about without worrying that's like when something happens, what happens if something inevitably fails. So we'll go through, just briefly go through modern architecture. I'll introduce Temporal and we'll see Temporal in action. So we start here, right? Everything is stateless and scalable. It's beautiful. So we should have stopped here, right? But then reality happens. Our system evolves. Yeah, our system evolves. We had more services. At some point we decide, okay, we need a service bus for sync communication. Maybe then we need some dead letter queue in case of failures, handling the failures. Then probably some cache for storing state. Maybe some cron job, like for long running tasks, right? And as developers, as architects, as developers, we draw a lot of pictures, but in most cases they are very generic. What actually gets to production is fairly complex, and it may look simple on service level, right? But what we are building inside is it starts to compound. Honestly, when we add more and more features, like the complexity is getting exponentially. The complexity honestly, when we add more features, it's getting exponentially more complex. The applications, the systems, right? We need to care of rollbacks, retries, state management, and as we scale and get more customers, reliability suffers as well because there are simply more components that can go down. Do you recall this? Yes, it's a nightmare, right? It's not a crash, but half success. And now, you're writing, manually writing the reconciliation scripts in the middle of the night to fix the issue. Everything works fine until some API goes down for an hour, and then your memory leaks, your threads hang, and eventually your system commits seppuku. What can go wrong definitely will. A process can, a process or service can fail, a database can go offline or fail, API can fail or time out. If you check microservices.io, there is so many different patterns, like Saga, transactional outbox, I don't know, I deploy consumer, circuit breaker, like a lot of them, like etc. In distributed systems, it's not. The question is not if something fails. The question is like when and how often. We spend 80% of our time like building the pipes, and only 20% of our time actually moving the water. As a result, developers become less productive and simply lose focus. What if you could stop writing the plumbing? What if your function can run like for 10 seconds or 10 minutes or even years, like regardless of server restarts? Temporal abstracts away the complexity of retries, rollbacks, queues, state machine, etc., which allows us to fully focus on business logic. Temporal is basically a checkpoint for your code. It transparently records the state. If the worker dies, it simply like it simply responds on the last checkpoint with all variables intact. Temporal operates with workflows and activities. You can think of workflow as a journey. So you have a sequence of steps that should be finished in order to complete the journey. And an activity is something. It's some risky operation that, yeah, if something goes wrong, we can simply start over. The workflow is basically the orchestrator. It's the what and when. Conceptually, workflow is a sequence of steps written in general purpose programming language. Workflows can sleep for days, can wait for human input, or react on some external signals without holding resources. And one of the primary things that workflow do is orchestrate the executions of activities. And here is where the messy world lives. The network calls, the DB queries, basically any side effect. If these fail, then Temporal handles the retries. Temporal records each side effect, and to recover, it simply replays your code. It's basically a time machine for your functions. So, but let's look a bit closer. Interesting. Just a second. All right. So yeah, let's take a look at very naive order service. So we have inventory service that allows us to resolve some item. Then we can charge for this order and then basically ship the order, right? And what actually can happen? Let's say, yeah, let's just let me run the application. So and let's place an order. So yeah, it's success, and if we check the logs, reserving one laptop, okay, reserved, then payment happened, then it was shipped, right? But if we, let's say if something fails, if we, for instance, shipping fails, okay, something failed, right? And if we check the logs, we successfully reserved the item. Payment was done, but shipping wasn't done. So it means that now, like, how would we handle it? Now we need to basically somehow write the reconciliation process for this situation, right? Let's take a look how we could build it using Temporal. So here we have a workflow. Let's first of all let's look at the workflow definition. We have a workflow interface with a single workflow method. All the workflows, they have only a single method. Here we have implementation for this particular workflow. It's completely the same. As you can see, there is no difference. And also we have activities that handle all of our side effects. This activity definition. And we have multiple activities like to finish this workflow. It's just just simple simple steps, like without any logic. Let's take a look how it works. This is web UI provided by Temporal. It's open source web UI that you can actually deploy in your environment and use it for your, to monitor how your workflows work. Yeah, let's place an order, and if we place an order, we can see here that there is some workflows running, and now it's complete. We see, okay, we reserved an inventory, like we reserved item, then made a payment, and yeah, shipped the order. Let's try to place an order, and yeah, let's say we place an order and application crashes. What happens? We see our workflow here, and as you can see, okay, it tried to charge, but it failed, so it will continue trying again and again until it's gonna be completed. So if I run the application now, give it a second. Okay, now we see that, okay, it completed. Let's take a look at another case when we have retries. As you can see, I configured the retry policy for these activities, and yeah, so it's gonna work maximum 30 seconds, start to close timeout is 30 seconds, and then it will try 5 times, and eventually, yeah, should fail. Let's try to place an order. Okay, it's completed, but then we can try again and see that there was some issue. It tried 4 times, and eventually it was completed. And here we can see on the web UI we can see the last failure. So this UI really helps you to like many developers really avoid even looking into the logs, because you already see the reason in the web UI. Now let's see how it deals with timeouts. We place an order, tries to charge the customer. Takes too much time. Yeah, and eventually it fails. And in the UI allows you to, for instance, if you see the failed workflow, you can simply restart it. For instance, start workflow like this one, start it from scratch, or you can simply reset the failed one at some point when it failed. So you can choose the exact point in time where you want to reset it. It's been reset. Let's take a look how it works with the compensations. Let me place an order. Okay. Let's see what happened. So here we see that we tried to reserve an item, we charged the customer, but we couldn't proceed with order, and the order failed. So we need to compensate this and basically reverse the flow. So we refund the payment and we release inventory. Let's try another case where we can, if we have a human in the loop, then we, I mean, the workflow allows you to send signals from external systems or from analysts, like whatever. I mean, you can use simply your API for triggering the signals. let's place an order, and we see that, okay, let me show you the workflow. So how we process the order? We resort in the inventory, and then we check, okay, if there is any threshold, like approval threshold, then we need somebody to approve or reject this order. So yeah, you can store the state inside the workflow without any atomic instances. Like it always executes synchronously, so you don't need to care about concurrency inside the workflow. It was a simple order, and the amount is relatively small, so we don't need any approval. But for larger numbers, we need an approval. And let me try something else. Okay, let's place this one. Now it's waiting, and it's waiting for approval from just external approval to actually proceed. So as you can see, the workflow is waiting for a signal. And just briefly, let me show you how workflow interface looks in this case. So we have a signal method for approval. This is our signal, and whenever we call the signal, state changes. And we also can use query methods to, in order to get the state from the workflow. Yeah, the order looks fine to me, so I can. Let's check this state. So we see that it's awaiting for approval. Let's approve it. It's approved. You see, okay, we charge payment, ship the order. Let's check the state, and we see that, okay, this workflow is completed. If we let's try to place something even bigger. Yeah, it's very big amount. I don't think we can approve it, so let's try to reject. And if we reject, we can check the state. Okay, the state is rejected, and here we see that it was rejected. And we simply release the inventory. And you actually can test your applications, your workflows completely the same way as you test any other application. So there is Temporal provides SDK, testing SDK for your workflow. So if you wanna write unit tests for workflows, it's completely fine. If you wanna write something bigger, you can use test containers and basically run the real workflow instance and get like everything from it, because this for unit testing it's very restricted. There is no not everything is covered, so only main things to test steps in workflows and activities. Let me show you that activities are actually Spring components. Any call that you everything inside workflow should be every call from activities is recorded as event in history. So it means that it doesn't matter where, if it fails here, then it will continue from this point after recovery. And testing is very simple. So you have a test workflow environment. You can register a queue, you can register your workflows, mock the activities, and test and test your workflows. So let me get back to my presentation. So here's just use cases examples that Temporal can help you with. Like payment settlement, ledger reconciliation, onboarding, transaction processing, account lifecycle management, and many, many more. What about performance and scale? In general, Temporal is limited with the resources that you provide. It's used by Netflix, Stripe, AI, OpenAI Codex to process like 1 million transactions per second. Don't use Temporal for like 1 millisecond latency. It's for reliability, not for speed. So it's not designed to. Also, don't try to use it with simple CRUD operations. Yeah, it's mostly for like some complex steps that you need to make reliable. So we are engineers, not plumbers. Let Temporal build the pipes, and we will build the house. Yeah, questions?